Hi guys, what is irrational number? Let's talk about the irrational numbers. So you might have heard this question a number of times. What is irrational numbers? If you see the definitions, they will talk about that any number which cannot be expressed in the form of numerator by denominator. That's called the irrational numbers. So what are those numbers basically? So those numbers, example, if I take 1.1, 01, 001 and so on. What happens? This number is not at all terminating and not at all repeating also. So these kind of numbers are called the irrational number. Example 1.3, 13, 113 and so on. So this number is also non-terminating, non-repeating. So this number also falls in the category of irrational number. Example 1.01, 001, 0001 and so on. This number is also irrational number. Let's talk about the another example. Root 2. The very common example of irrational number is root 2. Why do we say root 2 is an irrational number? Let's talk about it. Let's find out the value of root 2. Now, I open the calculator and let me find out the exact value of the root 2. And I opened. Now, root symbol and 2. So, I get the value of 1.414213564. Okay, and this calculator has the is finding till the 10th decimal place. So it has only 10 digits after the decimal place. And if you find it with another scientific calculators, you can see it is not ending. Okay, so this number is in the category of irrational number because none of the numbers are getting, none of the patterns are getting repeated now here, and it's not terminating also. Oh, that's why it's a irrational number. Now let's talk about the root 3 value also. Let me just find out what is the value of root 3 now. I find out the root 3 value. So yes, root 3 value, if you see, it says 1.73205080076 and so on. Again, so none of the numbers after a decimal place is repeating and it's not at all terminating also. So why do we say the number is not at all terminating? See, we can only find the numerator by denominator only when the number is terminating. If the numerator itself is not terminating, how are we going to find the denominator of it, right? So now let's talk about some of the important number which also belongs to the irrational number. So common example is the pi value. The pi is what? It's the circumference divided by diameter. So what is that value? That value approximates to 3.14 and so on. Again, if you just find out the exact value, 3.14, and keeps on repeating. Okay, so this number is also non-repeating and non-terminating. So that's why pi is irrational number. So sometimes we say that 22 by 7 is also pi, because see, we approximate that 22 by 7 to the pi value, but actually 22 by 7 is expressed in the form of numerator by denominator, so that becomes a rational number, but pi is the irrational number. Irrational number of the pi is 3.14, so on. Okay, and let's talk about some of the important properties of the irrational numbers. See, we got the irrational numbers. What is the sum of two irrational numbers? Sum of two irrational numbers is always irrational number because number is not terminating. The root 2, just now we saw the value of root 2 and another 2 root 2. When one number is not ending, another number, how will we add the two numbers when none of the two numbers are ending, right? So we have to take approximate, we have to stop at some place and then we add it. So we get approximate values. And that's how the sum of the two irrational numbers gives you the irrational number. What about the multiplication of rational number with the irrational number? If I multiply 2 into root 2, again, 2 is the rational number and root 2 is the irrational number. So what will be the answer now? Again, it's an irrational number only, because how will you multiply something which is not at all terminating at all, right? So we'll keep it like 2 into root 2 only, okay? And what about multiplication of two irrational numbers? It depends. If I multiply root 2 into root 2, then the power will get cancelled. It will come out of the root. So it will become the root 4 and 2 will come out. Okay, so that becomes a rational number. Now, if I multiply two irrational numbers which are different, example root 2 into root 3, how will you multiply it? See, if I take the value of root 2, it is not ending. Root 3, again, it's not ending. But we can multiply. Some of the properties says that we can just multiply, right? Because we can keep it in the root and 2 into 3, 6. So it's basically root 6. So when you find out the root 6, again, it becomes the non-terminating, non-repeating. Again, so it becomes the irrational number. So these are property. And another property of the division property. Let's talk about the division property. If I divide root 2 by root 2, I'll get a rational number because numerator and denominator both are same. It'll get cancelled and you get the answer as a rational number. But if the numerator and denominator both are different, example, root 2 divided by root 3, will you get the rational number? No, because the numerator is non-ending, denominator is also non-ending. Again, the division we keep it as root 2 by root 3. So again, we will consider as a irrational number. So it's all about the irrational numbers we discussed, guys. So I hope it makes some sense to you guys. And if you really like this video, give a thumbs up. And please write in the comment section if you want us to make some more videos on the simple maths so that it can clarify all the doubts whatever people have. Okay, with this we are signing off. Thank you.